This is a video on electrophilic aromatic substitution. This is covered in IB or first year university. So something to remember. The definition of nucleophile means that any reagent with a non-bonded pair of electrons that can be donated to a new atom or ion to form a new covalent bond. Or else a nucleophile is just a Lewis base. An electrophile is any molecule or ion that can accept a pair of electrons to form a new covalent bond. These are Lewis acids. Now, this mechanism derivation, what we're going to cover for this video is that if we have benzene, which is where I'm pointing at, and we react it with a halogen gas, such as chlorine, we actually need to react it with another compound, which is iron trichloride. And what we actually get as a result is chlorobenzene, just chlorine attached to the benzene ring, plus hydrochloric acid. Okay? So this derivation requires 3 steps. So if I just write step 1 here, what we actually want is to make an electrophile. And how we do this is by just having our halogen gas, which is going to be chlorine, and we know chlorine has 3 pairs of non-bonded electrons. And we actually add this to our iron trichloride. So just using electron notation, this breaks to actually form an electrophile, which is actually going to be chlorine positive, which looks weird. And we also have another funky species where we have iron tetrachloride. But iron is also negatively charged. So that's step 1. The important part of this step is that we actually get this. This is what we want to start our reaction. So with step 2, we actually have our benzene ring, and this is going to react with our chlorine electrophile. Now, one of these double bonds from the benzene ring is actually going to react and form another covalent bond with the chlorine electrophile. And this forms just another bond. But notice there's this positive charge from the chlorine has actually gone into the ring. So it's a carbocation now. Okay? Now notice we have to use a technique of resonance of the aromatic ring to stabilize that positive charge. So we can do that by just forming resonance structures. So this double bond is going to hit there, and then this double bond can shift over to this one to make one final resonance structure. So the importance of resonance is that this positive charge that we had here, that can actually be shifted from this position to this position to this position. So it actually stabilizes the positive charge around the ring, which is good. Now the last step, step 3, is that we have this. And now what we actually need to incorporate is a base. So if I have any sort of base, this base will have either a negative charge or a lone pair of electrons, and this base can act like a nucleophile. Okay, so finally these pair of electrons can actually, oh, and silly me, I forgot to put in the positive side there. So these lone pair of electrons can actually attack this hydrogen, and then this bond forms a double bond there, where we had originally taken it out. And this just equals our original benzene ring with a chlorine attached, plus a hydrogen and a base. So hopefully that makes sense, and good luck.